All right, so we're going to start with our solutions to last night's homework, which was on page 84. So first thing here, we have that the measured angle C is 50 degrees, and the measure of angle B is 80 degrees. In number 2, we have that the measure of angle B is 57.5 degrees. We have that the measure of angle C is 65 degrees, and that the measure of angle D is 57.5 degrees. Then we move over to number 3. We get that the measure of angle A here is 30 degrees. We get that the measure of angle B is 120 degrees, and that the measure of angle C is 30 degrees. And that problem X was equal to 6. And in number 4, you use triangle sum theorem. You get that X is equal to 12, that the measure of angle A was equal to 24 degrees, that the measure of angle B was equal to 24 degrees, and that the measure of angle C was equal to 132 degrees. Then we went over to page 85, where they asked you to find the value of X in this first problem. So in this first problem, the value of X was equal to 2. In number 6, they ask you to find the measure of X and the measure of Y. Well, in number 6, the measure of X was equal to 90 degrees, and the measure of Y was equal to 135 degrees. Then we went over to number 7. We had to find the value of X and Y. This one is almost exactly like one of the example problems from the notes. So we get an X value of 17, and we get a Y value of 15. Then we went over to numbers 8 and 9, where you needed to use the distance formula, or you could have graphed and used Pythagorean theorem. In this one, we get that triangle ABC is isosceles, and it asks us to name a pair of congruent angles. So based on the information that I got that angle A would have been congruent to angle B. Then for number 9, I got that triangle ABC is not isosceles. So when I went and found the side lengths there for each of the sides, it did not have 2 sides that were congruent, therefore it was not isosceles. So we're going to move forward today to page 91 in our Walch book. And on page 91, we're going to start talking about mid-segments of triangles and what you can say about a side length and its mid-segment if you are able to prove that it is, in fact, a mid-segment. All right, so here on page 91, you're going to see this image here, and it's asking us to find the lengths of BC, so that's this long line here that's one of the sides of the triangle, as well as YZ, which is a shorter side here of that triangle. So based on what you're looking at here, it's pretty obvious that you're going to have to be able to know some sort of relationship between those side lengths and what are going to be viewed as mid segments. So the way that we're going to do this is we are going to address it step by step. And so when it asks us to identify the known information, one of the things that we're going to do here is we're going to sort of try to identify what we need to know to be able to declare whether or not something is in fact a mid-segment. So ultimately, I'm trying to find the length of BC. So when I'm doing that, what I already know is several things. So I already know that, sorry, let me get a different color here. Now I'm going to sneeze. No, I'm not going to sneeze. Okay, so We already know a couple things. So this word here, mid-segment, should be, well, maybe is making you think of midpoints. So what a mid-segment is it is a line that goes through something from midpoint. It goes through a triangle because this is a mid-segment of a triangle, but it goes from midpoint to midpoint. So if I'm going to have what's called a mid-segment, I need to know that it is a line that goes from a midpoint to a midpoint. So if I look here, I know that I'm trying to figure out this line right here, BC. That's one of my things that I need to know. And I happen to see here that Y is in fact a midpoint because this 2-tick mark here and this 2-tick mark here indicates that the distance from Y to C is the same as the distance from Y to B. So one of the things that I know is that Y is the midpoint of BC. Okay, well, YZ here is a line. Well, Y connecting to Z here, we'll look at Z, I see that Z is also a midpoint. So I also know that Z is the midpoint of AC. So now, because I know that Y is a midpoint and Z is a midpoint, I now know that YZ is a mid-segment. Now, one of the things, and actually let's keep going because that's not all that we know there. So we know that that's a midpoint there. And if I'm looking at this, I'm actually able to identify that there is a third midpoint here, and that's point X here. So I also know that X is the midpoint of a B. And then I notice that Z to X goes from midpoint to midpoint, so ZX must be a mid-segment. All right, so right now you're like, all right, cool, these are mid-segments, why do I care? Well, there's some important information that is true if something is a mid-segment. So what is true is that a mid-segment is always going to be parallel to one of the side lengths. So because I already know that these are midpoints, I already know this is a mid-segment. But what that means is that this line segment XZ or ZX is parallel to CB. And what it also means is that this mid-segment ZY is parallel to AB. So one of the important things is that a mid-segment is always parallel to one of the side lengths. Now, here's the other important thing. Not only is it parallel to it, but the mid-segment is half the length of the parallel side length. So what that means is I now know that since ZX is a mid-segment because it goes from midpoint to midpoint, I also know that it has to be parallel to one of the side lengths. Well, it's very easy to say it's not parallel to either of those because it intersects those. It has to be parallel to this one. Well, now, because I know that these are parallel and that this is a mid-segment, I know that BC is twice the length of XZ or ZX. So now I'm able to find my missing side lengths here. So let's go ahead and solve this problem out. So it's asking me to calculate the length of BC. Well, I know that BC is going to be twice the distance of ZX. So I know that if I take 2 multiplied by the length of xz or zx, doesn't matter how you say it, that's going to be equal to the length of BC. So I can take that length of zx that I already know, and I know that that length of zx is 4.8. So that means that line segment BC is going to have to be 9 6/10 units. So I can go in here and I can say, well, I know that this side length here, or this line segment, is now 9 6/10 units. All right, we're good there. Now it wants us to calculate the length of YZ. So YZ is a mid-segment. It goes from midpoint here to midpoint here. So I'm going to locate its parallel. Well, there it is, its parallel. Well, I know that the outside side length is twice the length of YZ. So again, I know that 2 times YZ is equal to, I'm sorry, 2 times AB. No, I'm sorry, I'm doing it right. 2 times YZ is going to be equal to AB. So I'm going to go in there, and now I'm going to fill it. Now, of course, you could also take AB and divide it by 2, but we're going to set up an equation here. So I've got 2 times YZ. Well, I don't know what YZ is yet, but I know that it has to equal 11.5. So 2 times YZ equals 11.5. And when I divide by 2 here, I get that YZ has to have a side length of, or a length of 5 7/500. So I'm going to go back and fill that in here. So that's here. And then along here, I have 5 7/500. All right, so now I am supposed to calculate the measure of one of these angles here. So it is asking me to calculate the measure of angle AXZ. So that is A to X to Z. So it wants this angle right here. So they don't give us a lot of information here. So I need to start thinking about what I do know. And anytime they're asking me for a missing angle when they don't give me any information, I'm going to start looking for parallels and transversals. So what I happen to notice here, and I'm going to put it here in a different color, is that because I have a mid-segment here, I know that this line here is parallel to this line here. And then technically, this mid-segment could become a transversal. So now you've got your parallels and your transversals. You already know the value of this angle in here, or you're trying to figure out the value of this angle here, and you know the value of this angle here. So if you're thinking about these, there's an angle relationship between those angles, and you might have to turn your head so that the parallels look nice to you. But these angles here are inside the parallels, and they are on opposite sides of that transversal. So these are alternate interior angles. And because these are alternate interior angles, now you're looking at a situation where you know that this missing angle here, AXZ, is going to be congruent to that angle there. So AXZ is going to be 38 degrees because of alternate interior angles. So if we go to state our answers here, we know that BC was 9 6/10. We know that YZ was 5 7/500. And we know that angle AXZ was 38 degrees. So hopefully that makes sense, because now we're going to use that information to solve an equation. So here we go, moving on to example 2. All right, so here we are looking at an example where they're asking us to find the length of AB, and they've given us an expression for the value of AB and also an expression for YZ. So let's go look and see what we have here. So we know that YZ, which is one of the things that they give us here, is 3x minus 6.5. Well, YZ right here, Z is a midpoint. It is the midpoint of AC, and Y is the midpoint of BC. So right here, I have a midsegment. That means it is not only going to be parallel to one of the side lengths, but also half the length of one of the side lengths. So I go and I notice that it is half the length of this side length. So I know that if I take the value of my midsegment and double it, it's going to be equal to the value of my side length. So what I'm going to do here is I'm going to take that side length, YZ, that's a Z, YZ, and I'm going to double it, 2 times YZ, and that's going to give me the value of AB. So that's 2 multiplied by 3x minus 6.5 is equal to 2x plus 7. So when I go to solve here, I'm going to get 6x minus 13 is equal to 2x plus 7. I'm going to subtract 2x here. I'm going to get 4x minus 13 is equal to 7. And as I continue to solve, that's going to be adding 13. So I get that 4x is equal to positive 20. And when I divide by 4 on each side, I get that x is equal to 5. Now, it's important that we remember that this question did not ask us to find x. We had to find x in order to find our answer, but it's asking us to find the length of AB. So now I need to return to my question, and I need to take AB, which is 2x plus 7. So I need 2x plus 7, so that's 2 multiplied by 5 plus 7. So now I can state that side length AB is equal to positive 17. And obviously it's positive because it is a side length. So the next question is sort of an interesting one. And one of the things that I'm going to do is before we even start, I'm just going to I'm going to go to the bottom here and I'm going to kind of write down the steps. And the reason that I'm going to do that is because when you go to do these for homework, I mean, of course you could replay the video, but it's going to be nice just to have the steps categorized here, and then we are going to go through the problem together. So in this question, what they've done is they've given us the midpoints of the triangle. So I know that this is a midpoint of a side length somewhere, this is the midpoint of a side length somewhere, and this is the midpoint of some side length somewhere. And what I don't know are the actual vertices of the triangle. So that's what it's asking me to find. So I'm going to go, and this is the one where you need graph paper. So get your graph paper out. So in your Walch book, where it says number example 3, you can write these steps, and then we'll go back and do the problem. So the first thing that you want to do is you want to plot the midpoints on the coordinate plane. So you want to plot the midpoints. And if you look at that example, I've already plotted the midpoints. So that's your first step. So you plot the midpoints. Then you connect the midpoints in a triangle. So you connect midpoints to form midsegments. And the midsegments will be XY, YZ, and XZ. The third thing that you're going to do is you're going to calculate the slope of each midsegment. That's where that parallel piece comes in, because we know that parallel lines have the same slope. So if I know the slope of the midsegment, I can create the side length that has that same slope. So now I'm going to calculate the slope of each midsegment. After I've done that, I'm going to draw the lines that contain the midpoints. And that means the sides of the triangle. And I want you to remember it's going to be parallel to the opposite side. And I'll explain what that means. All right. So then the last thing that you will do is determine the vertices. All right, so if you now want to go ahead and get your graph paper ready, you're definitely going to want about the scale that's provided here, and it's intentional that that's the scale. So again, go ahead and get your midpoints plotted, and then we're going to get going. So again, pause the video, plot your midpoints, and then there we go. So at this point, we are going to connect to form the mid segment. So we've got X, Y, and Z already there. I'm going to connect them to form the mid segments. All right, so I know that these are, so like this is the midpoint of some line. This is the midpoint of some line. This is the midpoint of some line. So now, again, I want to calculate the slope of each mid-segment. So first slope that I'm going to find is xz. So I'm going to find the slope of xz over here, and I'm just going to count. So that's up 1, 2, 3, and over 1, 2, 3, 4, 5, 6. So 3 over 6. So the slope of xz should be 1/2. So the next thing that I'm going to do is I am going to find the slope of yz. So from this point, I go up 1, because remember, you always start with the point on the left. So I go up 1, 2, 3, 4, 5, 6, 7 over 1. So that's a slope of 7 over 1. So yz has a slope of 7. And then finally, I need yx. So again, I start at the left. So this is going to be a negative slope. I'm going down 1, 2, 3, 4. 1, 2, 3, 4, 5. So it looks like -4/5 is going to be the slope of that line there. So now I go, so that was step 2. I calculated the slope of each midsegment. So now I'm going to do that step that says draw the lines that contain each midsegment. So to do that, I know that the line that goes through point Z here is going to be parallel to this line. So, and that's what I mean by the opposite. So if I'm drawing the one that's parallel to this, it's opposite. It goes through this point. So I'm going to start at point Z, and I need a line that's going to be parallel to this. So I need it to have the same slope as yx. So I know that I'm going to have a line here that has a slope of -4/5. So I'm going to count down 4, 1, 2, 3, 4, and over 5, 1, 2, 3, 4, 5, and I'm going to plot a point there. Then I'm going to go down 4 more, 1, 2, 3, 4, and over 5, 1, 2, 3, 4, 5, plot a point there. I'm going to go back in this direction. If I was going down 4 and 5 to the right, now I'm going up 4 and 5 to the left, so that's 1, 2, 3, 4, 1, 2, 3, 4, 5, I think. Yup. Uh-oh. 1, 2, 3. Oh, go point. All right. So that line right there is going to be one of the sides of the triangle. And so, oh no. Okay, so this line here is one of the, it's like impossible, if only you knew. I bet there's like a tool that I could draw a line. I bet it's really easy and it's like right here. And then it's this one. Ooh, let's see what happens. Oh my God, that was special. Okay, so no experimenting. This is not the time for experimenting. It's all gone. Now it's back. All right, let's just put everything right back where it was. Okay. So now we're going to pretend like that's a line, but we know that there's a line there that is parallel to that line. Obviously, this looks so parallel. Okay, so we're going to go with the next one. So the line that goes through point Y here is going to be parallel to this line. So XZ had a slope of 1/2. So now I'm going to draw a line going through Y that has a slope of 1/2. Up 1 over 2, up 1 over 2, up 1 over 2. By magic, they have intersected, up 1 over 2. So going in that direction, I have a line and they intersected right there. That's probably important. Now I'm going to go down 1, 2 to the left, down 1, 2 to the left, down 1, 2 to the left, and then I'm going to go in that direction right there. Okay. So we're getting close. Some of you can already see this is going to be our last line. Those are our last intersection points because I know that the point that goes through X is going to be parallel to this line right here. So I need a slope of +7. So that's going to be up 7 over 1 and down 7 over 1. And sure enough, that becomes a point where they intersect and that becomes the point. So now we have found the vertices of our triangle. So I'm going to go list those vertices. So I started with the midpoints and now I know that the vertices of my triangle, they didn't tell us what the name of the triangle was. So the vertices are starting with the one in quadrant 3, -2, 3 is what that is, -3, -2. Then the one that is in quadrant 2 is -1, +12. And the one in quadrant 1 is 9, 4. So 2 of your homework problems are going to have you going through that process. So again, you will need graph paper. And if you're having trouble doing it, watch the video again. That is absolutely going to help you out. Don't just assume that because you did it once, you can magically do it. If you need to go back and look, absolutely do that because each one of those examples will have a nice clean set of vertices just like this one. All right, so number 4 here is pretty interesting. So what number 4 is asking us to do is something called a coordinate proof. So what a coordinate proof is going to do is it is basically it's manipulating these coordinates, which obviously you see here are not just given numbers, they're sort of rules, they're expressions that then would apply to any sort of triangle with side lengths that fit those prescriptions right there. But what it's asking us to do is to prove the triangle midsegment theorem. So the triangle midsegment theorem it basically says the midsegment theorem tells you two things. It says that the slopes of the midpoint or the slopes of the midsegment and side length are parallel, and that the midpoint is half the distance, or mid-segment, excuse me, is half the distance of that parallel side lengths. So what they're asking us to do basically is to prove that that's true. So they're asking us to take these coordinates that aren't specific numbers, that are universal, we could use them over and over, and then it's asking us to basically prove that the slopes are equal and that there is this relationship where one of the side lengths is always half the distance of the other. So here we go. So I've broken this up into some steps here. So the first thing that we are going to do is we are going to identify the known information. So if it's asking us to prove triangle midsegment theorem, we have to start with the triangle because we're trying to prove that DE is a midsegment there. So all we really know is that we have a triangle. We know that we have triangle ABC with vertices at, so we know that A is located at 2A, 2B, that B is located at the origin, and that C is located at 2C, 0. And those are the things that we already know. That's about it. So what we're going to do right now is we're going to do step 2. It asks us to find the coordinates of D, which is the midpoint of AB. So right now, it's telling us that that's the midpoint, so we want to find the coordinates of what that would be. Because if that is indeed the midpoint and this whole thing works out, then we're going to be able to prove that those are parallel and that that's half the distance of that. So midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So AB, those are my side lengths here. So for my x coordinates, I have 0 plus 2a divided by 2. And for my y coordinates, I have 0 plus 2b divided by 2. Well, 0 plus 2a, that's 2a divided by 2. And 0 plus 2b, that's 2b divided by 2. Well, 2a divided by 2 is a. 2b divided by 2 is b. So D is located at the ordered pair A, B. Now we're going to move over to the next step. So I know that would be its ordered pairs if it were a midpoint, and I want to find the ordered pair here that would make that a midpoint. So I'm going to use my midpoint equation again, but now I'm using A and C. So A is located at 2A, 2B, C is located at 2C, 0. So for my x coordinates, I have 2A plus 2C divided by 2. And for my y coordinates, I have 2B plus 0 divided by 2. Well, at this point, I can only do this, and this is something that lots of people start trying to do all the time. I can only divide both of these by 2, or I can only divide by 2 here because both of my coefficients are divisible by 2. Because basically what you can do here is you can factor out a 2, and then you have A plus C divided by 2. And when those divide, you're left with just A plus C. But people get in the habit of just dividing things randomly. You can't do that. Now here, this is still 2b plus 0, so that's just 2b divided by 2. So here I would get b. So the coordinates of E are A plus C, comma, B. So now we're going to go here. This is A plus C, comma, B. Now the next question, or the next piece here, is asking me to calculate the slope of the midsegment. Well, the midsegment right here is a horizontal line. So I do not need to calculate the slope of the midsegment, but if I really wanted to, I would use the slope formula. So that would give me, so I've got AB, and then I've got A plus C, comma B. So when I did the slope formula, I would get B minus B over A plus C minus A. So I would get 0 over C. Well, 0 divided by C is 0. So the slope of the midsegment, the slope of DE is in fact 0. We can do the same thing to find the slope of BC. So if B is located at 0, 0, we know that 2C 0, so that's going to give us 0 minus 0, over 2c minus 0. And 0 over 2c, just like 0 over c, is always going to be 0. So now I know here that BC is also, the slope of BC is also equal to 0. So if we go to think about our what we're trying to prove here, we've already proved part of it. We've proved that the side length is parallel to the mid-segment. And that's going to be helpful here as we now just need to calculate the distances. So we're going to use the distance formula here because the distance formula is going to allow us to deal with the coordinates very easily. So I'm trying to find the distance of DE, so I'm going to start with that's AB and also A plus CB. So I am going to take the difference of my x coordinates. So this is going to be A minus A plus C squared. And this, because that's the differences in my x's, I'm going to add that to b minus b squared. So this is a minus c squared plus 0 squared. Remember, this is distributing a -1, so that's a minus c. So that is the square root of, well, a minus a is 0, so this would be negative c squared plus 0. Well, what do you think? So right now, this is the square root of, well, negative c squared is just c squared. And we know that the square root of c squared is equal to c. So right now, I have proved that this piece here is equal to the length c. Now, in order for this to be a true midsegment, I need to prove that this is twice that distance. So I need this to have a value of 2c in order for this to be true. So we're going to go find the length of BC. So that is 0, 0, and 2c, 0. So that is the square root of 2c minus 0 squared plus 0, minus 0 squared. So this is just 2c squared plus 0. Well, when I have a squared out here, I need to square both things. So this is 4c squared. Square root of 4 is 2. Square root of c squared is c. So I have figured out indeed that my length BC is 2c. So at this point, I have proved the triangle mid-segment theorem because what I have done is I have proved that I've used these coordinates to state what my midpoints would be. Then I found that the slopes of the lines between the midpoints and the side that it is across from then would be parallel. We proved that. And then I proved that the midpoint is half the distance of the side length. So that is that entire coordinate proof there and the end of this lesson. This is one, again, as you're doing your homework, there might be little bits of this that you need to rewatch because the general idea of it's not so bad, but there are little bits and pieces that might be a little confusing. You might get hung up on them. So as you're looking at your homework for tonight, your homework is going to be on page 95. It's going to be page 95, page 96, page 97, and I guess you don't need to do 98 because it's the same as 97, and 2 is enough. So on page 97, when it says to use a coordinate proof, you don't really need to do it that way. Because, well, you do sort of. You have, but you have the actual coordinates, right? So you wouldn't need to use like weird A's and B's and stuff. But on page 97, in order to show that you would show that they're parallel and that the lengths are half, you of course need to find the slopes of, for instance, on number 7, you need to find the slope of BC. You need to prove that it's the same as the slope of EF. Then you need to find the distance of BC and the distance of EF, and then prove again that that half of the relationship exists. So I hope that that is helpful. And that is that. So we will go ahead and then check the solutions to this on Thursday. And then we will move on to our next lesson. So again, as always, reach out with any questions or concerns. This is sort of like a big concept that comes back sometimes. So make sure that you truly understand what it means by being a mid-segment and then what that implies about the paralleledness and the relationship between the lengths. So again, reach out. Hope you're well, and we'll talk to you guys soon. Bye.